In earlier presentations, I mentioned some pointer kung fu. This video is made to go deeper into the pointer topic in Cython. The way Python handles objects is somewhat like pointer operations, but a bit more complicated. Every object has an unique identifier that is created with that object. It resembles memory allocation, returning the pointer. When object is assigned to another, its identifier is just copied to a new variable. It resembles pointer copy behavior. Also, object maintains reference list for garbage collector to work, etc. This mechanism was described many times, so it's not a subject for this presentation. I mentioned it shortly just to refresh the understanding. Interesting that C++11 introduced similar mechanism named smart pointers. Code created by Cython uses C++ pointers to PyObject struct instances, it's obvious. But it also offers you tools to control pointer operations. Pointer variables are defined very similar to C using cdef keyword. Then you can easily use libsys, malloc and free. And of course, we have all the power of memset, memcopy, strlen and other low-level C functions. Indexing the pointer dereferences it. Look how easy you can make pointers within array elements. Note that we can, and mostly have to, cast the pointer type to maintain logical integrity at compile time. The typecasting syntax might be confusing for C++ programmers and pretty new to Pythonists, but I think it's done so to avoid ambiguity. Now I'm going to show you a library I wrote to achieve my goals at job. You can see a typical Cython header file used to include C headers and describe functions and structures used in our code. I call it libifaddr, that obviously stands for Library for Interface Addresses. To be honest, the main of its task is covered by Python's third-party netifaces module, but I find netifaces not very comfortable to use and somewhat bloated. Also, it is one more dependency. Finally, I need an easy conversion between strings and 64-bit integers for Ethernet addresses. That's why I created that library from scratch. Luckily, it's also a great demonstration for this presentation's topic. The link to full source code will be put in the description, and you see a QR code for it. Instead of C's malloc and free, it is recommended to use corresponding functions from PyMem group, like this. When you work with strings and byte arrays, you must remember that Python strings and C character array pointers are different things and need to be converted to and from. Python 3 has two types of string-like arrays, Unicode strings and bytes objects. Difference between them that bytes objects represent raw binary data, while Unicode strings works on character level. I'm sure you know that Unicode character can be up to 4 bytes long. Therefore, if you want to convert a Python string to bytes, you must encode it with codec like UTF-8, UTF-16, etc. And vice versa. If you want to convert bytes to string, you must decode UTF-8 or UTF-16 byte stream to characters. C strings do not have such difference, so from Cython perspective, they are just arrays of bytes. Luckily, Cython developers made the conversion process as easy as assignment between different types of objects. Even easier is using C++ standard strings. You just can create string objects and use it directly as if it were bytes objects. Don't forget to encode and decode it. C++ code should be generated and compiled a bit different than C code. In this video I showed you again that Cython is not just a Python compiler, but rather a broad bridge between Python and C++. This is achieved with Python language superset offered by Cython. It allows you to use C, C++ features still being comfortable with simple Python-based syntax and all the Python code base and community. Just a little effort is needed to dramatically improve the performance and efficiency of your Python code. Computers are nothing but automated slide rules. They are expensive, dumb and slow, so don't make them do anything beyond the necessary. save the CPU cycles. That I was told by my teachers decades ago. Things have been changed nowadays, but not very much. You still need more and more performance, so don't waste CPU cycles. If you find this content interesting and or useful, please let me know by clicking different YouTube buttons around the video frame and or in comments. Thanks for watching. Bye.